Yeah, I'll quickly go over these because I did assign them, and then you know where you're at. Okay, so we had still solving graphically. I will just quickly, right, if I call this 1 and 2, we have y is equal to negative x plus 4. That means that my y-intercept is that, and my slope is negative 1 over 1. And for the second one, I have y is equal to negative 2x plus 6. You start at 0, 6, and the slope is negative 2 over 1. So both of these lines are going downwards. Yeah. So 0, 4 here. It's 1, 1, 1, 1. That's good enough. So you go ahead and graph that. And this is x plus y is equal to 4. That's that line. And then we go over to this one where we have 0, 6. I have to expand this a little bit. 6 there. And then we have negative 2 over 1. Negative 2 over 1 there. So we have our 3 points. Line them up. You have to be problem solvers if it goes out of the grid, right? And this is 2x plus y is equal to 6. The POI is definitely 2, 2. All right, and then just go ahead and I'm going to under this one, left hand side, right hand side, right? We have x plus y is supposed to be 4. 2 plus 2 is 4. Left hand side is equal to right hand side, so we're good there. And then we have left hand side, right hand side for the second one, where it's 2x plus y is equal to 6. So it's 2 times 2 plus 2. That's 4 plus 2, which is 6. Left hand side is equal to right hand side. Therefore, 2, 2 is the solution to the system. Okay? Keep it there for a bit. Copy that down. Okay. So at least write down the solution so you can do it yourself, right? If you're running a little behind, because I want to get to the next part of this chapter. So here we have another one, 2, 3, and 3. So I'll call that number 1, number 2. So for the first one, I will rewrite it immediately, right? So I'm just bringing the 2x over, divide everything by 3. Y is equal to negative 2/3 x plus 1. So 0, 1, and slope is negative 2/3, and which is going downward, right? And then for the second one, negative y is equal to negative x plus 4, right? The x comes over subtracting. I divide everything by negative 1 or multiply everything by negative 1 is the same thing. So you have 0, negative 4, and my slope is 1 over 1, and that's positive, so I'm expecting it to go up. Okay, so 0, 1 is here, and then it's 2, 3, 2, 3, right about there. Draw your line. Go past the points. And we have 2x plus 3y is equal to 3 here. And then we have 0, negative 4. And it's 1, 1, 1, 1. Keeps going. You can see that it's going to cross there. And this is x minus y is equal to 4. And our point of intersection is 3, negative 1. Left-hand side, right-hand side, we have 2x plus 3y equal to 3. So it's 2 times 3 plus 3 times negative 1. So that's 6 minus 3, which is 3. Left-hand side is equal to right-hand side. And for the second equation, we have left-hand side, right-hand side. There probably will be a double negative there. It's x minus y on the left, and it's equal to 4 on the right. So that would be 3 minus negative 1. This turns to positive, right? So it's 3 plus 1, that's 4. Left-hand side is equal to right-hand side. Therefore, 3, negative 1 is the solution. And remember, I told you always go back to the original when you're checking, just in case you made a mistake in rewriting. You will find out that you made a mistake, right? And this one, it should be pretty straightforward. Determine the solution in each system. So this would be negative 1, 2, right? And here the solution is 4, negative 5. Yes, you probably should be plugging it in, but we're just going to leave it. So there you have the solutions to this last portion of graphing, solving by graphing. And now we're going to have a different, the other two methods are non-visual, right? They're abstract, but they're more efficient and faster, and especially if the points aren't whole numbers, right, where the lines meet. So we're going to go there. Okay, 7.4, solving a linear system by substitution, right? And right, by substitution, that's what we're doing today. That's what we're focusing on. And each way of solving has its advantages. Okay, we usually use this method. Watch this. When one of the variables, right, one of the variables has a coefficient of 1. That's the best application of this. It doesn't mean that that's the only way. Again, technically, you should be able to solve a system by graphing, by using substitution, and the next one, which is elimination. Like, you can use all three methods, but one is better than the other, right? One is more efficient at doing that than the other. Okay, so we're going to solve by substitution. So you notice here, out of the two equations, try to find one equation that has a variable with a coefficient of 1. And that's this one right here. If you look at both, they all have, this is a 2, 4, 3, right? They all have coefficients greater than 1 except for y. Okay? And then isolate equation with a variable that has a coefficient of 1. Okay, that's the game plan here. So let's call this our first equation and our second equation, right? So we know what we're doing here. So let's take the first one, isolate y. That's basically what we're going to do. So you go 2x plus y is equal to 3. The y stays. the 2 comes over subtracting, and the 3 is already there. Okay, so what you're saying now is that, remember, if this is a system, that means that both of them are happening at the same time, right? And if there is a solution, then there will be one point where they meet. So from the first one, you deduct that y is equal to negative 2x plus 3, okay? So underline this portion here, right? We're saying that in this system, y is equal to negative 2x plus 3. And then sub into the second equation. We're going to substitute this, right? We're going to look for y in our second equation, and we're going to substitute that in with negative 2x plus 3. So we go 4x plus 3y is equal to 5. We're going to go 4x plus 3. I'm going to slow down a little bit here. 4x plus 3. What we're going to do is we're going to take this and substitute that in for y in the second equation. What's important to remember is that if you're taking the first one and you're isolating for y in this case, we can also isolate for x. It's not fixed. It's just that I identified the one that has a coefficient of 1. It could have been in the second equation. In this case, it was in the first. So don't be too fixated on this is how it's always going to work. Think about, right, the big picture here. What are we doing? We're finding the variable with a coefficient of 1. We isolate that variable, right, so that it is on the left side, everything else is on the right side. And then we go to our other equation, not necessarily always the second, right? It's just the other one. And you substitute that in, right? In this case, y is equal to that. Well, guess what? We're going to go to our second equation and replace y with the negative 2x plus 3, okay? So we're going to go like this. And I'm going to use a different color here. Negative 2x plus 3. Okay, so that it kind of stands out a little bit. That's what substitution is, right? You're substituting in to the other one. Okay, we're not done yet. So we substituted in for y, and then we got to complete that and saying, hey, that is equal to 5. So it's still the same equation, except for we substituted in what we found up on the first one. I hope that you follow so far. And now, right, now that you've done that, now isolate x, right? So now watch this. We completely got rid of y in the second equation. It's all in terms of x, which is great. It could all be in terms of y. It depends on the scenario, okay? But everything is in terms of x. That's exactly what we want. So now you got to apply the algebra rules, right? Distribute if you need to, and so forth. So 4x plus, we're going to distribute this. 3 times negative 2x, right? That would give you negative 6x. Let's put that in brackets, right? Because it's negative. And 3 times 3 is 9. And that whole thing equals to 5. And then we can now say, hey, 4x plus and minus just goes minus. And let's clean this up. This will be negative 2x. I'm going to bring the 9 over to the other side because that's what I want, right? The 9 comes over subtracting. Just change the sign when you bring it over. So that's negative 2x is equal to negative 4. Divide both sides by negative 2. And you can conclude that x is equal to positive 2. So here, a lot of students, or quite a few students, think I'm done now. I did my, like, this is it. I found out what x was. I'm done now. Remember, you're trying to find a solution to a system. So let's say we're going to conclude here, solution is a point, right? You just found the x portion of this, right? So we know that the x value of the solution is 2, but we don't know the y value yet. This is unknown, okay? Found the x value of solution. Now we're going to find the y value, okay? So I'm also going to go over, from this, I'm also going to go up like this, and we're going to say sub into 1 or into 2. It's up to you which one you want to substitute that value into, right? So going back to the two equations that we had, you can take the x equals to 2 and substitute it into either one. Both should give you the same y value that you're after, okay? So we're gonna, I choose, pick the one that's easiest, okay? So it's 2x plus y is equal to 3. We found that x is equal to 2, right? I will erase that and use a red pen on that one. Or I should probably use blue because I used the other one. So 2 times 2, that's 4, plus y is equal to 3. We say that y is equal to 3 minus 4, y is equal to negative 1. And this is now what goes into the y value like this. And you just solve the system, okay? So we've figured out our y value, and now we're going to verify it makes sense. So the first one, always take the original, is 2x plus y is 3. 2 times 2 plus negative 1. That's 4 minus 1, that's 3. Left-hand side is equal to right-hand side. It took seconds for us to do that, okay? We're going to do the second one here. Left-hand side, right-hand side. I'm going to use the original, 4x plus 3y is equal to 5. We go 4 times 2, right? I'm using the solution here, plus 3 times negative 1. And that's 8 minus 3, that's 5. Left-hand side is equal to right-hand side. Therefore, 2, negative 1 is the solution. Okay. So a lot of stuff here, I know, and it's probably busier than what you thought, but later on we're not going to have as the steps in detail as that. We won't be using up that much space down the road. Okay. So let's keep going. Okay. just going to pause. So here we go. We're going to do the second one. I want you to almost rewind the tape of how we got these equations. So what I'm going to do is I'm going to change all these coefficients to put a 3 in front of x, change that to a 6, and change, no, sorry, a 9. This is a 9, sorry. And change this to a 6. So 3, 9, 6. Make sure you change that like that. So we're kind of changing the system a little bit. So 3x plus 9y minus 6. We're going to call this 1, and we're going to call this 2. The reason I did this, I basically multiplied this whole equation by 3, the whole thing by 3. I want you to start realizing, remember the GCF, like finding a common factor. If you see that every number can be divided by 2 or by 3 or by 5, like if you see a common factor across the whole thing, I want you to go ahead and divide everything by that factor, right? So we're going to take this one, and if you do that to the whole equation, you're not altering it. We're going to change that, and that turns out to be x plus 3y is equal to -2. Okay? Do this if you can, if you see it, because it's going to make your life a lot easier. Okay? It's going to make it a lot easier. And watch this. By us doing that, we realize that, hey, we have, it happens to be the first one again, the first equation, but we will still call this our first equation, okay, after doing that. We found one that has a coefficient of 1, okay? So in first one, isolate x. So we're going to take x is equal to -3y minus 2, okay? And then sub into the second one. We're going to take this, I'm going to underline that, and we're going to take our second equation. So that's -3x plus 5y is equal to 6. And in this case, we isolated x. So we're going to plug this part into x here, and we're going to use a different color. -3y minus 2. Make sure you don't forget your signs or anything. And please hang in there. Don't go just yet, okay? So we substitute this. I'll put an arrow into there, okay? And that turns out to be this. Let's distribute that. So that would be positive 9y plus 6 plus 5y is equal to 6. And here you can speed up the tape, right? Because 9 and 5 is 14y. And on the other side, it's 6 that is already here. And this 6 comes over subtracting. So it's 14y is equal to 0. If you divide both sides by 14, y is still equal to 0. Okay? So it's one of those, right? If you divide 0 divided by anything is always 0. Okay? So I would actually box this in because that's part of your solution. Okay? So if you want to write down solution at the bottom here, you know this part here. You can go ahead and say, yeah, my solution is going to have 0 as its y value. But we're also going to take this and continue our journey. Sub into 1 or 2. You can choose which one you would like to plug the y equal to 0 into. Sorry, I can't see that. Either one of them. I will purposely pick the second one this time. So it's -3x plus 5 times 0 is equal to 6. That's negative 3x is equal to 6. Divide both sides by negative 3. X is equal to negative 2. I know I'm speeding up here. And this goes in there as negative 2, 0. So we know, we're pretty certain that that's our solution. We're going to verify, and that's going to be it for today. On the first one, left-hand side, right-hand side. Oops. Just hang in there, okay? I'm almost done. So 3 times negative 2 plus 9 times 0 is supposed to be equal to negative 6. We get negative 6, so left-hand side is equal to right-hand side. We're done that. And then for our second equation, I apologize, I try not to do that, but I feel like we need to finish this here. Negative 3 times negative 2 plus 5 times 0 is supposed to be equal to 6. 6 is equal to 6. Therefore, negative 2, 0 is a solution. Okay, before you go, homework 7.4, page 425. I'm only going to assign a couple. 4 to 7. And 19, leave that for now. Just do 4 to 7 for now. After tomorrow's lesson, you'll be able to do 19.